So hello everyone, in the previous session of stack we have seen what is stack, implementation of stack. We have seen various methods like how to implement stack using arrays, array list, linked list, and after implementation we have seen some of the basic questions of stack like pushing element in the bottom of the stack, reversing a particular stack, and reversing a particular string using stack. And after that we have seen a medium level question called as stock span problem. Now in this session, what we are going to do is we are going to solve some of the important questions which you may find in competitive coding platforms. In some interviews you might find these sort of questions. So these all questions which we are going to do is first of all hard level question, and after it we are going to do all this question using the concept of stack and in linear time complexity. If you do this sort of questions with normal looping or iterative method, then you may get a quadratic, or you can say big of n square time complexity. Now what we are going to do is, by using stack we are going to reduce the time complexity of this question by linear time, that is big of 1. So let us start with our first question. So in this question what is given is that we will be given by a array. Like let's say that this is the given array as our input. Now what we have to do is we need to give the resultant. The resultant of this question is nothing but the next greater, or you can say the next immediate greater element. For example, let's say that this is a element, this is a given array. Now what I will do is I will iterate through each and every index of my array, and when I iterate, what I will do is I will check the next greater element which is present in my rest of the array. If the next greater element is present, then I will add that element at the first index of my next greater array. For example, let me show you a dry run for this question. Now for this question the given array is ERR is equals to 6, 8, 0, 1, 3, right? Now what I'm going to do is I'm just talking about what is asked in the question. So what I'm going to do is I'm going to run a loop and I will iterate through each and every index of my array. Now for the first index, what is the next greater element? For 6, the first element is 6. So then I will iterate for, let's say that I is equals to 0. Then I will start my inner iteration, or you can say my second iteration, from I is equals to, or let's say that j, the iterative variable is j, from j is equals to I plus 1. So I will start my iteration, second iteration, from the next element, right? So I will start my next iteration from here, and I will check whether my given index value is less than my second iterative value. If it is, then I will add that particular element immediately into my next greater array. So what I am going to do is I will create first of all a next greater array. As how many elements we have? 1, 2, 3, 4, 5, right? So 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. Okay, these are the indexes. So what is the next element present, immediate next element present after 6? That is 8. On the right side, I am going to check the elements which are present on the right side of my given particular element. So what is the element which is greater than 6 on my right side? That is 8. So if it is present, if I got a next element immediately, then I will stop my loop and I will include that element into my next greater array. So what I will do is I will include 8 into my next greater array at 0th index. Now I will move to the next index. So for 8 I will check for the rest of the array. So for 8, 0 is not next greater, 1 is not next greater, 3 is not next greater. So if my next great element is not present for a particular index, then what I'm going to do is at that particular index I'm gonna store -1. So here at the first index I will store -1. Now for this 0th element, for this next index, I will start and I will check for this rest of array. So for 0, the next immediate greater element is 1. So I will add 1 here. Now for this 1, the next immediate is 3. So I will add 3. Now for this last element there is no right element anymore, so for that I will add -1. So this is my answer. So this is the basic asking of my question. So I will return this array to my user, or I will print this array to my user, that's all. So this will be my answer. So this is the basic asking of next greater element. Now what is the approach for this question? If I talk about the brute force approach, then you can see that we are running two loops, or you can say two iterative statements. This is my first iterative statement and this is my second iterative statement, and I am running outer loop from I is equals to 0 to the size of a given array, and the inner loop is, let me show you the pseudocode such that you will understand. So in brute force what we are doing is, first of all we are running a loop, outer loop, for I is equals to 0 to I should be less than arr dot length, and we are incrementing the I value. And in the inner loop what we are doing is, for j is equals to I plus 1 and j should be less than arr dot length and j plus plus, and in this we are checking that if arr of j is greater than not equals to, so greater than arr of I, then what we are going to do is, at that particular ith index in my next greater array, so next greater of ith index is equals to, I am going to store the arr of j value. I hope you are getting it. And I am gonna stop my loop. First of all, after this I will break immediately, because I got my next greater array, next greater element, and no need to check for the rest of the array. So I will break from here, and if I didn't got, then what I will do is I will put next greater of that particular ith value is equals to -1. So this is what I am going to do in my basic brute force approach. So you can see that I am running two iterative statements, that is first of all for my outer loop, for the outer loop of the rest of the array, and let's say that this is my index. So after this index I am checking for the rest of the element present after this particular index, that is my inner loop. So outer loop and inner loop. So if you see for just the overview of it, then you will get that the time complexity for brute force approach will be big of n square, right? But in this question what we are going to do is, we are going to use the stack approach, and by using the stack approach we will reduce the time complexity to big of n, right? Now let us talk about the stack approach of this question. So let us say that this is my given array, arr is equals to 68013. Now what I am going to do is, first of all I will create my next greater array. Next greater is equals to, I will create 5 elements array, 0 1 2 3 4, right? This is my next greater array. Yeah, let me make it a little bit. Yeah, so this is my next greater array. So what I am going to do is, let me write the first step such that you will understand. So the first step is, while my stack is not empty, and my stack of top is less than or equals to arr of j, then what I am going to do is, I am going to pop the element, so s dot pop. Else what I will do is, if my s dot is empty, if I popped all the elements, I am just writing the pseudo code and I will show you the demonstration of how this code will work. So if is empty is true, then next greater element, if there is no element present in my stack, then what I am going to do is, next greater is equals to -1. If some of the elements, if there are some elements present in the stack, then next greater is equals to s dot s of top element, and the third step will be s dot push that particular element. So this is the basic approach. Now let me show what I'm talking, what is this pseudocode. So this is my array, right? So in this question, for stack approach, what I'm going to do is, I am going to iterate from the reverse side of my array. So I'm going to iterate from this side. So here you can see that my stack is empty. So if my stack is empty, then what I'm going to do is I will add this particular element in my stack. So I will add this element, and for the first element if I am adding, then I am going to store at that particular index -1, because there is no right element. We already know that for the last element there will be no right element. So for the last element I am going to store -1, right? After that I am going to iterate for the next element. So for 3 you can see that stack of top is not less than this particular element. So here stack of, what is stack of top? Stack of top is 3, and DRR of j, that is nothing but this element 1 is. So here you can see that 3 is not less than or equals to 1. This is not true. So if this is not true, then I will come to my next statement, second statement. If stack is empty, whether the stack is empty? No, the stack is not empty. So I will come here and I will make sure that next greater is equals to stack of top. So here the next greater is, what is the top element? 3. So I will add 3 here. Now after that I will push the element in my stack. So I will push 1 into my stack and I will iterate to my next element. I hope you are getting it. Now for 0, stack of top is 1 and the element is 0. So 1 is not less than or equals to 0. So I will not enter my loop. So after that what I will do is I will check whether in my second step whether stack is empty. No. Then the top element will be stack of top. So what is the topmost element? 1. So for the second index my top value will become 1. After that I will push 0 into my stack and I will iterate to my next element. So here you can see that the stack of top is 0 and 0 is less than 8. So if it is less than, then I will pop this element, and again I will check. This is a loop, right? So I will iterate back and I will check. So here after popping 0, then what is the top element? 1. So 1 is less than 8. Yeah, again pop 1, and again I will iterate back and I will check whether stack is empty. No, it is not empty. And whether 3 is less than 8. Yes, 3 is less than 8. So I will pop here, and after popping all elements my stack will become empty. So if my stack is empty, I will come to second step now. If my stack is empty, then next greater will become -1. So I will add -1 here. After that else the value will be so if my stack is empty, the next greater will be -1. After that I will come to my third step. So I will push the 8 value into my stack. So I will push 8 here, right? After that this is my last element. I will come to my last element. So while my stack is empty, not empty, and 6 is 8 is not less than, the top is 8 and 8 is not less than 6. So I will not enter this loop and I will come to my second step. So if stack is empty, no, stack is not empty. So I will come to else step, and here in the else step I will add the top element. So what is the top element? 8. So I will add 8 into my stack, into my next greater element. After it I will add 6. Finally this is the resultant value. So the value will be 8 -1 1 3 -1. So this is the answer I will get. Now let us code this thing and understand how the code works. So in the main function, I am going to remove all this. So in the main function what I am going to do is, first of all I am going to create our array. As we have taken the example, I will create that particular array which is 6 8 0 1 and 3. After creating, I am going to create my stack of integers. Let me give the stack name as s. S is equals to new stack. And after creating stack, I am gonna create a int next greater value. So next greater array is equals to new int of arr.length. And after that I am gonna run a loop for int I is equals to arr.length -1. From the last element we are iterating. So arr of length -1, and I should be greater than or equals to 0, and I minus. In this, what we are going to do is I'm going to run a while loop. So this is my step 1. Step 1 is my while loop. So while my stack is not empty, s dot is empty, and then stack of top, or you can say ARR of s dot peak is less than or equals to ARR of I. If this is the case, that is nothing but if my top element of stack is less than ARR of I, which is nothing but the iterative, or you can say that particular element present in my array at that particular index. So I am iterating from my indexes, right? So in that particular array, if that particular element present in that particular index is greater than my stack top, then what I am going to do is I am going to pop the element. So s dot pop. After popping, this is my second step. Now second step is if else. Second step is if else. So in the if else, if my stack is empty, then what I am going to do is I am going to assign next greater is equals to next greater of I is equals to -1. Else what I am going to do is next greater of ith element is equals to stack of top. So s dot peak, ARR of stack of peak, right? After that, I am gonna push. This is my third step. Push elements, push that particular element. So s dot push that particular ith index. After your loop got terminated, run for int I is equals to 0 and I should be less than next greater dot length and I plus plus. In this print system dot out dot print, let me remove ln here. Print, you can give next greater of that particular ith element plus some space. Now let me save this program. So this is a program of next greater element. So in this, I'm gonna save this and run. Let me run this. So you can see that we got the output as same as we dry run before, that is 8 minus 1 1 3 minus 1. So this is the approach of you can see that how many loops we are using. We are basically using the outer loop, and in the inner loop we are basically checking whether the stack is empty or not. We are not iterating for n elements. So in the brute force approach we were iterating for n elements, whereas in the stack we are not iterating for n elements. That is why the time complexity of this question is next greater question time complexity will be big of n, right? I hope you got the approach for this question. Now let us talk about another question. Now in this question, user will give a string containing characters, and these are the specific characters. These are nothing but brackets, curly brackets and square brackets, right? And we need to determine that whether the given string is valid or not, and what are the conditions for a given string to be valid is given here. So you can see that the conditions are open brackets must be closed by the same type bracket. It means that let's say that we have a square opening bracket, then it should have a corresponding closing square bracket. This is the first point, and the second point is opening bracket must be closed in the correct order. So what I mean by that is that it should be symmetric in nature. So what I mean by symmetric is that let's say that this is my opening bracket and opening square bracket, and after that I have a opening curly bracket. So I should not have a parenthesis or a system like this, because this is not symmetric in nature. So for this particular question my answer should be false. So it should be symmetric. So what I mean by symmetric is that it should be in same order. Let's say that I have a curly bracket, so after this I should get a curly bracket first, after that a square closing bracket. So this is, if you break it down, then I should get a symmetry. So it should be even in nature, right? And the third point is every closing bracket should have a corresponding opening bracket. So in this example, you can see that I have a opening square bracket. For that corresponding, I have a corresponding square closing bracket, and after that I have a opening square curly bracket, and for that I have a corresponding closing curly bracket. So it should have a opening and a like closing pair. Second point is it should be symmetric, and the third point is the opening bracket should have a closing bracket. So for example, you can see that this is a given array, given string, and you can see that here we have closing parenthesis, and after it we have a opening parenthesis. After it we have a square closing bracket and square closing bracket, and similarly we have a curly bracket, opening and closing in pair. So this particular string will give me true as my output, and for this particular string there is a opening parenthesis and there is no corresponding square, or you can say there is no corresponding closing parenthesis. So for this particular question we will get answer as false, and similarly for this also we will get false, for example. And you can see that this is a basic example. We have a closing parenthesis and the opening corresponding parenthesis. So for this particular input we will get output as true. So this is the basic asking of my question. So what are the three conditions? Closed bracket should have a closing closed parenthesis will have a opening corresponding parenthesis, and it should be symmetric in nature, and each bracket will form a pair if they are symmetric in nature, and if there is an opening and closing bracket they form a pair. So these are the three conditions you have to keep in mind. Now let us see how we are going to do this question using stack. So let us talk about this approach. So for that, let me take an example, like let me take an example of this closing parenthesis, this. Okay, so for this you can see that there is a corresponding opening and closing parenthesis in symmetric nature. So for this particular question my output should be true, right? So initially what I will do is, first of all I will form a stack. Let us say that this is my stack, and I will follow two-step approach. This is a two-step approach, right? So if I got a opening bracket, then what I will do is, first of all I will immediately add that opening bracket into my stack. So I will do s.push. After that, if I will check after first step, I will check for my corresponding closing bracket. So if I got my corresponding closing bracket, then what I will do is I will check first of all if my top value which is present, if the bracket which is present in my stack is corresponding to my like closing bracket, and if they form a pair, then I will what I will do is, if it forms a pair, then I will pop the topmost element and I will iterate to the next element or next string, next character. If it doesn't form a pair, if the pair is not formed, then I will immediately return false. So this is the basic idea of doing this question. Now you can see that, let me show you a dry run. So this is my output I have taken. So I will I will take this input as a burger form. So this is the output, right? This is the input. Right, so I will iterate from the first element. So this is the opening bracket. So if this is the opening bracket, then I will add into my stack, and after it I will iterate to my next element. So this is also a opening curly bracket. So I will add again, and again you can see that this is a closing square opening square bracket. So I will add again into my stack, and this adding will continue until I get a closing bracket. You can see that this is a closing square bracket. So for this I will check the now my iterative step is at that particular index I got a closing square bracket, right? So I will check the corresponding top element. So the top element is this opening square bracket. So if I got a corresponding pair of brackets, then what I will do is, first of all I will pop this element and I will iterate to the next step. So I got this element and the top element is this. Again they form a pair. So this is the pair I'm getting. So if I got a pair, then again pop the top element, and again you can see that this is the opening element. So if I got opening element, now my stack kind of look like this. So for this particular index I will add here this. Now I will iterate here, and again I got a corresponding pair. So if I got a pair, this is my closing and this is the pair I got. So if I got a pair, then I will pop the top element, and after that I will move to the next element. So here the next element is this, and the topmost element is this. Again we form a pair, then I will pop the topmost element. Now my stack will look like this. So finally my third step will be, if my stack is empty and if there are no elements present in my string, that is I iterated through each and every element in my string, for that what I will do is I will return true. Else what I will do is I will return false. So this is the basic approach. So what I am doing is, I will tell you again that first of all I am iterating through each and every index of my given string, and if I got a opening bracket, then I will push that bracket into my stack, and if I got a closing bracket, then I will check the corresponding pair with the top element. Let's say that I got a square closing bracket. So I will check the top element, whether the top element is a opening square bracket or not. If it is a opening square bracket and the index which I am iterating is a closing square bracket, then these two will form a pair. If they are forming a pair, then I will pop the topmost element and I will iterate to the next index, right? If it is not forming a pair, then I will immediately return false. I will terminate my loop, return false to my user, and that's all. The question is completed. And after checking all the pairs and popping the elements in my stack, if the stack is empty and I have iterated all the elements in my given string, then and only I will return true, else I will return false. I hope you got the approach. Now let us code this thing. Now for this question, let me create a function, public static boolean. Let me give is valid. In this I am passing my string str. In this I am creating, first of all I am creating a stack of let's say that I am creating character. Yes is equals to new stack, and after that I am running a loop for int I is equals to 0 and I should be less than str.length, and after that I plus plus. In this char ch is equals to, I am taking the each character of my string, so str.caret that particular ith element. Now if I got a opening bracket, that is ch, if ch is equals to let's say that I got opening bracket, right? I am checking for my opening brackets. So if I got a curly opening bracket, let's say that ch is equals to this curly bracket, or ch is equals to my curly opening square bracket, right? So if I got any of these three, then what I will do is I will push s.push this particular stack, this particular ch value into my stack, right? This is my pushing statement. So whenever I get a opening bracket, I will push that particular element, that particular character into my stack. Now let us check the closing condition. So for closing condition, I will check else. In the else, if they are forming a pair, that is ch is equals to if the character is a closing parenthesis, if it is creating a closing parenthesis, and s dot peak is equals to let's say that I have a opening bracket, or let's say that let me copy the same thing, right? If we have a closing curly bracket and the topmost element in my stack is a opening curly bracket, or let me give here, if my top ch value is a square bracket and I got a opening square bracket in my stack. If any of these three conditions is true, then what I will do is I will pop the element in my stack. So s dot pop. Else what I'm gonna do, if there is no pair formation, then immediately return false. After it, if after running all the loop, if my stack is empty, if stack is empty, s dot is empty is true, then return true. Else if there are some elements in my stack, then it shows that there is a inequality, or you can say it is not some of the opening braces for that particular opening bracket, there are no corresponding closing bracket, right? So if there are elements present in my stack, then what I will do is I will immediately return false. That's all. Now in the main program, I'm gonna remove all this and I'm gonna create a string str. String str is equals to, I am taking the example which we have taken before, that is let's say that we have a curly bracket, a opening bracket, and after it, yep, this is my string. Now I'm gonna call my function, and whatever the function returns me, I'm gonna print it. So I'm calling isValid function and I'm passing str. Now you can see that for this particular input, I will get my output as true. Now let me see what output I will get. You can see that I got my output as true. Now we are going to do another important question, which is maximum area in a histogram. So a histogram is basically a rectangle. You can consider that a rectangle formed out of a given bar graph, and we need, if I say layman's language, if I say in layman's term, we need to find the area of maximum rectangle that can be formed for a given bar graph. This is the basic language I can use here. Now in this question, what we will be given is a integer array representing the heights of each bar in a histogram, and we need to find the largest area, the largest rectangle that can be formed out of this histogram. And you can find this question in various competitive platforms, and you can find this question in like big companies as well, and this is a very important question at the same time. So in this question, what will be given is a height array, and the width of each bar is given as 1. Now the width of each bar is fixed, which is 1, and the height is given as my input parameter of my question. Now we need to find the maximum rectangle area that can be formed out of this histogram. So what I mean by rectangle is, let me show that this is the given height, right? 2, 1, 5. These are the heights of my bar. 6, 2, 3. Right? Now the width of each bar is 1, 1, 1, like this. Now you can see that out of this particular rectangle, out of this particular bar, let me change the ink such that you'll understand it. Now for this particular bar, how many rectangles I can form? I can form only one rectangle, because if I move forward it, I can't create a rectangle anymore, because there is a break point in between it. There is a inconsistency, you can say, in between the bar 2 and bar 1. But let me change the pen such that it will be good for you guys. Yeah, let me change it to black. Now but I can create a rectangle for this bar 2. I can create this rectangle, right? And for this bar 5, the rectangle that can be possible is this. And bar 6, the only possible rectangle is this. And for bar 2, the possible rectangle is this one. I hope you are getting it. Yeah. And for bar 3, the only possible rectangle is this one, right? So we need to calculate the rectangle that can be possible for the each bar. And after calculating the area that can be formed out of that bar, we will take the maximum, you can say, value that we will get after calculating the rectangle area for that corresponding bar. Now let me show you how we are going to calculate the bar area, right? So this is my, this is my height, right? 2 1 5 6 2 3, and the width is, we know that the width is 1. Now what I will do is I will iterate through each and every bar, and while I iterate through each and every bar, I will calculate the rectangle that can be formed out of it, right? So for 2, the possible rectangle can be, you can see that I can't move backwards because there are no bars, and I can't move forward because if I move forward, then you can say I will fall down, or there is no possibility of moving down because the boundary ended there, right? If the next bar, or let's say the bar, ith bar value is less than my the chosen bar value, then I can't move forward. This is the first condition I extracted. So the first condition is, this is my boundary condition, that is, if my ith, let's say this is my ith value, and I am iterating and checking, and that checking I am choosing another iterative variable j. So for my ith value, for my ith iterative index, if my jth index, ARR of jth, is less than ARR of ith, then this is my boundary condition and I can't move forward. So you can see that here I value is 1 and the j value is I value is 2 and the j value is 1. So I got this condition, and if I got this condition, then I can't move further, I can't move forward. So for this particular question, the possible, for this particular bar, the only possible rectangle is this one. So for this particular bar, the possible rectangle is 2, area of rectangle is equals to height into width, right? So the height is 2 and the width is, we already know, 1. So the possible rectangle area is 2. Now for this bar 1, you can see that I can move here, 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 and I can move as well as left direction because there are no boundary conditions for this particular bar, because all the corresponding bars are greater than my current bar, the current iterative bar. So if all the corresponding bars are greater than my current bar, then I can iterate through each and every index and I will calculate the area out of it, right? So for this particular 1 bar, you know how many, the height is 1 and how many bars I can iterate? 1, 2, 3, 4, 5, 6. So the width will be 6. So the answer will be 1 into 6. So for this bar, the area will be, the area of rectangle is 6. Now for this 5, how many bars I can iterate? I can't iterate on the left side because the left side bar height is 1, and if I got this particular condition, that is, if either my right side or my left side value is lesser than my current bar value, then that is my boundary condition. And if I got my boundary condition, then I can't move any further. So that is why for the 5th bar height, for this 3rd bar, which is nothing but value is 5, for this value 5th bar, I can't move left side, but I can move on the right side. Right, I can move on the right side because the value is 6. So I will move here, but I can't move further anymore because after 6 I am getting 2, which is less than my 5 value, right? So the bar height will be this 5 and the width is 2. How many bars I have iterated? 2. So for this, the area will be 5 into 2. So for this bar, the area is 10. Now for this 6th value bar, I can't move on left, I can't move on right because those two values are lesser than my bar height. So the area will be 6 into a single bar width 1. So 6 into 1 will be 6. Now for this 2, let me change the ink. So for this 2 value, I can move on the left side and I can move on the right side until I hit my 1. Right, this will be my boundary condition. This will be my boundary condition. So the area will be 1, 2, 3, 4. So the width is 4 and the height is 2. So 2 into 4, the value will be 8. Now for this 3, I can't move on the left side because as I move to my left side, for the first iteration itself I got my boundary condition, and I can't move towards right because there are no elements. So the area of this particular bar will be 3 into the width, which is a single bar, so 3 into 1, so the area will be 3. So what is the maximum index? Maximum value I got is 10, so the answer will be 10. So this is the basic asking of my question, and when you are solving this sort of question, let's say that you got a question of histogram, then you will take easily around you can take 40 to 50 minutes to solve this question, because this is a hot level question, and initially to understand the logic or basic asking of this question, you will get you might take some time, but after you are clear with what is being asked in the question, then you can move forward and you can think of the approach. Now here let us talk about the approach of this question. Let me change the pen ink. So in this question, what we have given is, we are given a height bars, height of each bar, it is 2, 1, 5, 6, 2, 3. Okay. Now what I have to do is, I have to move each and every index of my bar and calculate the left. Let me before we moving forward, area of rectangle, we already know that area of rectangle is height into width. Here we already know the height. The only problem for calculating the area of rectangle for a particular bar is how we are going to calculate the width. If we can find a way to calculate the width of a particular bar, then the problem is sorted. Now to find width, let us show how we can calculate a formula, or you can say a general idea of how we can calculate width. Now for this particular, let's say that for this first bar, let us go with the first bar. So for the first bar, the next immediate element is the next immediate smaller element. I am talking about next smaller element. So if the next smaller element is, you can say that, you can see that the next smaller element is 1, and what is the index, which is also 1. So the width is equals to next smaller right index, next smaller left minus 1. So this will be my width. How I got this? You can say that for this first bar, the next element is at the first index, and there is no left element. So the next width value will be next smaller right, which is second bar, minus will be no element present, so 1, 0 minus 1, so the value will be 1. The width value will be 1. Now let us see for this particular fifth bar. So for this fifth bar, next smaller right is at what index? 0, 1, 2, 3, 4, 5. So at the fourth index we have our next smaller right, and at first index we have so minus 1, so the width will be 4 minus 2, so the value will be 2. So this is how I am gonna get the next width value by calculating the next right and next smaller left. So I need to calculate, if I can able to find a way to calculate the next smaller right and next smaller left, then I can calculate the width value, right? So this is my formula for calculating width. So width is equals to next smaller right of that particular ith element minus next smaller left of that ith element minus 1. So this is my width formula, and if I can able to find a way to calculate the next smaller right and next smaller left for a particular bar, then I can calculate the area of that particular rectangle formed out of that bar. Okay, now let us see, if I see the code, we see the code, then we will get clear on how we are going to find the next smaller right and next smaller left. Now first of all, I am going to create a function, public static void max area In this I'm passing a integer array, and first of all I am creating int max area. Max area is equals to 0. Int max area is equals to 0. After it, int next smaller right is equals to new int of arr dot length. Arr dot length. After it, int next smaller left is equals to new int of arr dot length. Right, so I have created two empty arrays of arr dot length size, which is next smaller right and next smaller left. Now I'm gonna create my stack. So stack of integers, integer yes is equals to new stack. Now I'm gonna run a loop for int I is equals to arr dot length. Arr dot length minus 1, and I should be greater than or equals to 0, and I minus minus. Now in this I'm gonna run a inner loop while my stack is not empty, and arr of s dot peak is greater than or equals to arr of I. Now if this is the condition, then I'm gonna pop the elements in the stack. After popping, I'm checking if my stack is empty, then nsr of next smaller right is equals to arr dot length, else next smaller right of I is equals to s dot peak, and push the ith element into the stack. S dot push particular ith element. Now let us see how we can calculate next smaller left. So for this, again I am creating s is equals to new stack. So whatever the elements in the stack is there, I am emptying them, and after that I am running a loop for int. So this is the code for next smaller right. Now let us see how we can calculate the next smaller left. Running a loop for int I is equals to 0, and I should be less than arr dot length and I plus plus. In this, while s dot is empty, arr of s dot peak is greater than or equals to arr of I, then what we will do is s dot pop. If my stack is empty, if s dot is empty, then nsl of I is equals to minus 1, else nsl of I is equals to s dot peak and s dot push the ith element. That's all. For my current width is equals to j, width is equals to j minus I minus 1. I am running a loop for int I is equals to 0, and I should be less than arr dot length and I plus plus. In this, first of all I am creating two variables. Int height is equals to arr of I, and int width is equals to nsr of I minus nsl of I minus 1. After that, int current area is equals to height into width. After that, max area is equals to max area comma current area, right? And finally, after calculating overall area of the histogram, I'm gonna print system.out.print. I'm gonna print maximum area of the given histogram is plus max area. That's all. So in the program what we did is, first of all I have created a int max array, int max integer which is initially assigned with 0, and I have created two arrays, next smaller right and next smaller left. So in the previous question we have did a question called as next greater element. So I have used the same code which we used there for calculating next smaller right and next smaller left. But if you see that code, you will find the only difference here is that instead of less than or equal to, I have used greater than or equal to, right? So to calculate the next smaller element, this is the only change we have used here. And by using this, the same code which we did in the previous session, in the next greater element, we have used the same code here to find the next smaller element for both my right side and my left side. So this is my code for finding next smaller right, and this is the code for finding next smaller left. So we already know that area is equal to height into width. We know the height, but the problem we were getting is with only with width. So to calculate width, we have found out a way that if we can find the next smaller element which is present on the right and the element which is present next smaller element which is present on the left, if we can find a way, then we can calculate the width. So we know that width is equal to next smaller right index minus next smaller left index minus 1. This is the formula we came up with when we were talking about the approach of this question. Now what we did is we calculated the array. We have created the next smaller array which stores the value of next smaller element for a particular bar. Let's say that if I am at the 0th bar, which is nothing but the first bar, if I am at the first bar, then the next smaller right of first element will give the first bar, like you can say what is the next smaller element index. Got my point? And similarly, next smaller left will store the index of a next smaller element present for a particular bar. After calculating the next smaller left and next smaller right, I am iterating through each and every index of my bar, and while I am iterating, I am calculating the current area, and I am taking whatever the maximum area I am getting out of this, and after calculating the maximum area, I am printing the maximum area value. Now let me save this thing. Now in the main program I have taken some values, and if I run this code, then I will get whatever the maximum area will get out of this histogram. Now let me save and run. You can see that we got the output as maximum area of the histogram is 20. So this is how we will do the question of histogram. First of all, we will calculate the next smaller right and next smaller left, and after calculating we will calculate the width. So width is equals to next smaller right minus next smaller left minus 1. After calculating width, we will calculate the current area, and we will compare that area with the maximum area. If my maximum area is greater than my current area, then my area value will become my maximum area. If my current area is greater than my maximum area, then my area value will become my current area. So whatever the maximum value is there, we will taking that maximum value, that value only. So this is how this whole code, let me show it here. So this whole code is a code for calculating the histogram area. Right, I hope you got the basic logic and the code for this question. So with that being said, we have completed our stack chapter, and in the next chapter we are going to talk about another data structure which is queue, which will be like very similar to this thing, to stack, but it is totally reverse of stack. So with that being said, I will see you in the next one.